Welcome to our last video of the school year. I'm going to be running through the questions on our final review guide, and then we will be done with science for the entire year. It's crazy that we already made it to this point. Okay, so let's start with the first question. This unit has been all about waves, right? So the first question on here is about what is a wave? If you consider it by itself, what does it do? What is a wave? A wave is something that transfers energy from one place to another. So it's energy in motion. It's energy on the move. So if you have two objects slam into each other, they create energy in the form of sound waves, in the form of heat waves through your hand, a tiny little bit. But that's how the energy moves away from that impact, is through the sound and the heat. And in some cases light, but not usually with clapping. Okay, so let's look closer at a wave. What is the name for the distance from the crest to the crest on a wave? So if a wave is going up and down, what is the distance called from one crest to the next? That's called the wavelength, and it can tell you how much energy the wave is holding. If the wavelengths are close together, that is some really powerful waves. But if they're farther apart, they're more gentle waves. They're carrying a lower amount of energy. So it's the wavelength is that distance. The next question is, what's the height? So from the bottom of the trough to the top of the crest, that height is the amplitude. And that can also tell you how much energy the wave is holding. So higher amplitudes equal more energy. Lower amplitudes mean less energy. Then the last thing is, what's the name for how fast a wave is moving? So if we can look at one spot and see how quickly the crests and troughs are passing that point, that's called the frequency. And it's measured in hertz, H-E-R-T-Z, which stand for 1 cycle per second. So 1 cycle of crest and trough per second. Then one well-known type of wave is a sound wave, and we already mentioned that. What kind of a wave is a sound wave, though? In water, you always get transverse waves, which are up and down classic ocean waves. But sound waves are different. They spread out in all directions, so there's nothing to go up or down. It is called a longitudinal wave because you get compressions and rarefactions, like stretching and squeezing of the air as the wave pushes outwards from the object that made it. So they're called longitudinal waves. Next question is, in sound, if you change the amplitude, how does that sound in the wave of the sound wave? If you increase the amplitude of the wave, that increases the loudness to our ears. That's how you turn up the volume, is you increase the amplitude, the energy that the wave is holding. If you change the frequency, how fast it's moving, what does that sound like? That, to us, is how we experience pitch. So high pitched sounds have a shorter, or have a quicker frequency, a shorter time between cycles, and a lower sound has a longer frequency, a longer time between cycles, so it's moving slower. That's why when you take a slow-mo video, everyone sounds really like they have a deep voice, it's really slow. It's because you're literally slowing down the sound waves. With both sound and light, when they interact with a new material, like sound waves traveling through the air and then they hit the water, or if you're traveling through air and you move into glass, like with a laser, you can see this happen. There's a phenomenon called refraction that happens where the waves are bent in the direction of the material because they're slowing down. It's like a surfer, or what are those called? A water skier. When they fall and hit the water, they slow down immediately and they fall behind the boat because they're slowing down because of the impact of that new material. Same thing applies to waves. They get slowed down when they enter a thicker material, something that's harder to move through. So that is refraction. The next one is, what does a decibel measure? So decibels are how we measure how loud a sound is. So if you have a very loud sound, it has a high number of decibels. Low sounds have low numbers of decibels. We also learned about light waves, which are also called electromagnetic waves. What is the name for the type of light or electromagnetic wave that we can see? That type of wave is called visible light, which makes sense, but that's what the specific term is for it, visible light. All electromagnetic waves are part of the electromagnetic spectrum. how do the light waves change as you move up the spectrum? The spectrum is ranged from low energy waves all the way up to high energy waves, and they change by their wavelength as they move up. So waves at the bottom, long wavelength, low energy. Waves at the top, short wavelength, high energy. That's how they change. Which electromagnetic waves have the most energy? The ones at the top, they are called gamma rays. Gamma rays have very, very, very tiny wavelengths, and they carry tons of energy. A lot of nuclear reactors or nuclear radioactivity gives off gamma rays, which are the highest energy waves, light waves that we have found. Which have the least energy. Least energy is the radio waves. This is actually what we use for radios, is these very low energy light waves, but we can still transmit a signal through them and can read them as through the radio systems. When your eyes are seeing different colors, what are you actually seeing? Because everything around you is reflecting light. It's all light. But what's different, it's not like there's red light or yellow light. It's really just light waves of a specific wavelength. So we can measure this actually. It's like 500 to 550 nanometers would be a certain color. Or 550 to 600 is another color. Each one has a specific narrow band of color range that the light waves reflecting off that substance are when they reach your eyes. So each one has its own specific length of wave. That's what you're seeing. What happens when light strikes a certain kind of atom? So what happens to the electrons? When light hits an atom, it obviously interacts with the electrons first because they're on the outside. What happens when it hits one of them is it bumps that electron up to the next level of, like, the next energy state, the energy level, the energy shell all around the electron. So it bumps it up one. And then when that electron goes back down, it releases energy, usually in the form of light. So you have light coming in, energizing an electron, and then light coming back when the electron de-energizes and drops down to the state below. So then we had a picture of 4 different waves, and we had to say, okay, which one is carrying the most energy? And it was wave number 4 that was carrying the most energy because it had such a short wavelength. Shorter wavelengths equal more energy. It also has a very large amplitude, so it's carrying tons of energy. And the very last question is which one was carrying the lowest? This one was a little harder because some of the waves there was one wave that had a longer wavelength but had a bigger amplitude, and one that had a smaller amplitude but a shorter wavelength. I think the best answer here is number 3 because it has such a longer wavelength than number 1. Although number 1 it also is pretty close. So the answer to the last question is number 3. So on the test we won't have something quite as confusing. It'll be very clear which one I'm talking about. But that's it. That wraps up our study guide, and that wraps up the last chapter of our physical science class this year. I just wanted to say to everybody in 8th grade, I have really, really enjoyed having your class this year for science. I know we've done a lot of fun stuff. We've had a lot of silly moments. I'm thinking back, and some of my favorite things were like when I brought in the Van de Graaff generator that made everyone's hair stand on end. That was a lot of fun. When I forget, this might have even been last year, but when we had helium and I drank helium, and that was really silly. I remember taking a video of that. It was great. And how could I forget the pepper? The pepper that Toby brought into class. Oh my goodness, it was so hot. That was really fun. So we've had a lot of great memories this year, and I just want to wish all of you the best of luck in high school. I will be praying for you, and you can always send me a message if you have a question about science. I will do my best to help you out. And I will be watching the graduation live stream this Thursday. So good luck, have a great summer, and enjoy high school to the fullest. See you later.